In continuation with the previous video, that is video number 15, cells and its combination. For the fixed combination of cells, we have made the simplified diagram as, the simplified diagram is a single cell. It is converted into single cell with internal resistance equivalent, that is R equivalent, and E equivalent with external resistance R. External resistance R, where this is the EMF of a single cell and R is the for a single cell. Also we have derived the expression for E equivalent for this mixed combination is equal to N times of E, and R equivalent is equal to N into R by M, where M is equal to number of rows, N is equal to number of resistors connected in series, and R is equal to, so R total is equal to R plus R equivalent is equal to R plus NR by M. And the expression for I, the expression for I is equal to EMF, net EMF divided by R total, that is R plus NR by M. This can be written as I is equal to M N epsilon divided by MR plus NR. This is the expression for current in the mixed grouping for N number of identical cells, each cells connected in a row. Now we have also seen in that the for maximum current, the MR or plus NR, MR plus NR is equal to MR whole square under root minus NR whole square plus 2 into under root MR into NR. This we have seen it, NR into this we can write it separately, and this has to be 0 for maximum current, which we have derived the condition for I max. The condition is MR should be is equal to N times of R. This is the condition we have derived it. So for I max, for I maximum current in the mixed grouping, this has to be 0. Then what about this? This expression is represented by this equation. This has become 0. So this will become Mn by epsilon naught. This is represented with this equation with this portion is equal to 0 divided by 2 into Mr into under root Nr. This is the condition for I max. We have derived it for the I max. So we can simplify this also. How we can simplify? See, I max is equal to, we can write under root Mn into under root Mn, this into epsilon naught divided by 2 into under root Mn into R, cancelling these two. So for I max, the condition is E by 2, EMF of a single battery divided by 2 into under root, both we can combine Mn divided by R into R. This is the condition for maximum current. This also can be modified. Since Mr is equal to Nr, we can write Mr is equal to Nr. This implies R is equal to Nr by M. We can write R is equal to Mr by N. So we can write this way also. So for I is equal to I max, we can write to under root M into N we replace this R now. When we replace R, this will become m r by n into mr by n into r. So this m gets cancelled. When it gets cancelled, this is equal to epsilon by 2. Since this has been cancelled, this r will go under root n square divided by r square is equal to epsilon by 2 into n by r, or we can write I max in another form of I max is equal to this by this into n divided by r, where r is the external resistance. This way also it can be written, this way also it can be written for maximum current. Maximum current, once again we can write from the same expression. We are taking everything from the I max is equal to epsilon by 2, this expression, 2 into under root mn divided by r. Previously we have replaced this r, now we will replace this r. So this is equal to EMF of single cell divided by into m into n divided. Now we are going to replace this capital R, that is external resistance, is equal to R into nr divided by m. So now this will become is equal to epsilon by 2 into this, and this get cancels, under root m square by r square. So I max can also written as epsilon by 2, cancelling this one, into m by r. This is also the another expression. This is I max, this is first expression, this is the second expression. It is only simple manipulation. This is the third expression. So for I max we can write, either we can, in the competitive examination, if they are asking for I max, with this equation also can be used, this equation also can be used, this equation also can be used, and over that the main condition for I max is, I max means we have to use this condition, m into r is equal to n into smaller, m into r, this one, this should be equal to this one. With this condition only we derive this equation 1, 2 and 3.